Hello, good evening, everyone. Thanks for attending our session. A very good evening to Bhargavachari. Thanks a lot,
Good evening.
Bhargav, for accepting our invitation to give on
It's
composite material. So, in short, I would like to say about Bhargav. Bhargav did MS Masters from Germany, and he is working there in a company called AMC. So, he'll be talking about that about in his introduction. First, I would like Bhargav to thank from our academy for accepting this invitation and presenting to our uh, members who are interested to learn in composite materials. Thanks a lot, Bhargav. You can start the session.
Yeah, can you hear me properly, right? You can hear me properly,
Yes,
right?
yes, Bhargav, we
That's,
can hear you
yeah, that's
completely.
perfect.
Yes.
Yeah. Uh, First of all, good evening. I think it's a evening in India. Like, good evening, everyone. Samir, Danish, Miss Kavita, and then Miss Saurav, Mr. Saurav. And thank you very much for attending this session. And thanks a lot, ma'am, for introducing me and then also like gave me an opportunity to present regarding the composites. So in today's session, like I would like to just give a basic impulses regarding what the composite materials are and what can we do with the composite materials and what are the types of composite materials, and yeah, so all about composites that we'll be reading today. So I would like to share the screen and then I'll be presenting regarding the composites. So coming to myself, like I'm Bhargavachari. Then I've been did my bachelor's in India. I think most of you are mechanical engineers over here. So
Yes, Bhargav.
similar to you, like I have done a mechanical engineering in India, and then I have done masters here in Germany. The reason is like I've worked a bit in the composite materials after my bachelor's. So I thought I have to learn something more regarding the technologies, further technology and further advancements in the composites. So that's the reason why like I came to Germany, and then I have done the masters, and then currently from past 2.5 years I've been working in AMC with an innovative process technology which is called as XFK in 3D. It's also related to the composites. So we'll be also dealing a bit regarding this technology in our later session. So to give you the basic idea, and Miss Sunita like was a founder and CEO. Like we have been in contact and we have been in working with various lots of projects regarding the composites. It's not new to her. So yeah, so that's the
Thank you,
reason how
Bhargav.
like we have been
Thank you.
connected. And then
Yes, to know,
when
to
she's
mention, yeah, to just add a point to whatever Bhaga said. So actually from German and from India, we are mutual partners in terms of consultancy related to composite projects.
yeah, which is the main her core skill was like design and simulation, which is very important for the sustainable world right now. Like instead of making all the components testing directly, so what our cooperation involves was the design and simulation of all the components before making the test. So obviously, like the test results and the simulation both have to be matched to get the component get released. So this was our cooperation, and now let's jump into the topic. So I think like everyone are there right now.
Yes, they'll be there, Bhargav. Yeah, you can continue.
Okay.
Yes.
It would be nice like if you give some sort of yes or no the responses at least in the chat. So we think that there are some guys who are listening. Let me scroll this here. Yeah. So basically the composite materials. What are composite materials? So in general, like before entering into the concept of the composite materials, like we have been making rotis, for example, in house, and then chapatis, rotis, some different dishes. Where in the chapatis, for example, when we are making it, we have some of the grains which are the reinforcement, and the water which we add to make the dimensional stability is the water, like it's called as matrix. So here the composite materials in the engineering terms, like it's a mixture of two or more different materials. It's a combination, it's a mixture of two or more different materials where the individual properties are lower than the mixed. So in a simpler words, if I would like to tell, like it's a mixture of two different constituents or the materials, and by the mixture of these two materials, the properties are enhanced and raised than that of the individual components. So here one material which forms a matrix and the other one is a reinforcement. So the reinforcement meaning like it gives a strength. The matrix which is used for and the matrix is generally used for the dimensional stability, the structural stability of the component. So the major concern, the major thing which we have to do when we are mixing it, which we have to consider is that the material should not be chemically inert, because when during the composite manufacturing process, like when we keep it in oven, so one compound, one material melts and flows into the other material, this all things, it should not be happening. So it should be chemically inert, but they have to be adhesive and dimensionally stabilized to each other. So coming to the basic, the fundamental definition is it's a materials with two or three different materials, which is a combination. By mixing them, which forms a supernatural power or super mechanical properties material. So this is generally about the composites. So where do we use the composites? Composites nowadays, like they have been used in boat hulls, for example, the boats, which you can see the figures in further charts, and in the aerospace industries, where the lightweight is a major potential barrier, potential criteria which has to be considered, because the fundamental use, the reason for the use of the composites is to have the structural and also the lightweighting potential. For example, the carbon fibers, which are around 8 times less than the aluminium with the equivalent strength. So that's a reason, and that's one of the reason with the equivalent mechanical properties. So in aerospace, for example, when we have done one of the case study, like where we have made the seat, like which is around 8 times less than the standard seat what they have. So it's around 10 grams, 10 kgs, and the normal seat was around 40 kilos. So we consider the 180 seats in the whole Airbus or in the aviation, any aeroplane that we see. So it reduces around 2 tons. So the reduction of this 2 tons, it can travel, we can enhance the range, or we can enhance the kilometers or the range that it could travel with the most safest and lightest environment. And also in the automotive, and also in our day-to-day activities like sinks, bathtubs, and even in the bridges here in Germany, like we have the composite bridges, like where all the laminate has been separate on the sheets form, and then the composite wires, it has been joined to the concrete or to the material which is there on the ground. So it's for the also the bridges. This is lightweight bridge, and the main reason for this lightweight bridges are like they'll be manufactured at some exception place, and then they'll be bringing it for in a transportation, and it's just a modular concept. So they are surfboards because when a mountaineer, when he goes to the top of the mountain, then it's not, there should not be any heavy thing that it will be attaching on top of it, like because it's too stressful, and it's not so easy to carry the things on top of the mountain. So even on the snowboard, skis, and even the golf clubs, and also the hockey sticks, if you have a hockey stick of 10 kilos, then it's too difficult. So they are also used in hockey sticks, which are very strong enough in terms of strength. When there is some misuse or some unwanted force that are acting. And basically, even we see the composites in the trees. When you just cut the tree there, for example, if you have the banana tree, so where each and every layer of the leaf has some element inside it, which it comes out. So it's a fiber which comes out. If you just open a banana, there are some of the fibers which are there inside the banana. And then the thick one, it's called the matrix. So that's nothing like, it's a combination of matrix and the reinforcement. This matrix gives stability, and reinforcement gives the strength to the whole component. And in almost every places, the awareness, I would say, like regarding the composites has been going on, and it has been advanced in such a way that it's an industry 4.0 process which is happening, and it's an easy manufacturing processes also. So these are the composites used for the application. So in short, like it's used in every market segments, not only specified to certain fields, but it's used in each and every market segments. For example, if you learn the simulation or the design of the composite materials, there's nothing like you have to go only into the automotive or only into the aerospace industry. So you are eligible for each and every industries for the future or for right now where they are using the composite. So it's not particular to the it's not particular to the market segments, but it's used in almost each and every market segments. So you will be having all the opportunities in all the market segments that you'll be involving in the future as a mechanical engineer or as a civil engineer, or regardless of the engineer. Like if you know the design, simulation, and the production methodologies, then you are eligible in all the market segments. It's completely widened. So these are the applications. Coming to the applications. Here, like for example, these blades, the aerospace segments, and this whole fuselage. This is called as a fuselage, and then this whole fuselage is also made with the carbon fiber. So there are different technologies. So it's not only single technology; there are different technologies when it comes to the manufacturing process. And here, like if you see this, the whole frame is made with the pultrusion process. For example, this pultrusion process, it gives a intelligent use of the fibers, for example, so that it has a very high end strength and stiffness, and also ultralight thing that will be coming from when we make the composite frame for the bicycles or for the motorcycles. We are also making some of the motorcycles frame for the two-wheelers in India, right? For the whole with the composite materials. So it's completely light, and even now like 4 to 5 people can sit on a motorcycle, then 2 or 3. So it's completely safe, and then it's completely worthful with the price. So here, like coming to the engineering, as I've told you, like it's used in aerospace, automobile, and also the pressure vessels and pipes. In the aerospace, all the components, for example, we have done a couple of projects for the aviation segment, like where we have used the natural based materials like the reinforcement. So we'll be looking into it further, like what's the reinforcement, what are the materials that used for the reinforcement, and what are the matrix materials that they'll be using, and how the combination should work. So, and coming to the pressure vessels, this pressure vessels, like if you see like the cylinders that are there in the house, so it's too heavy to lift it up. So for that reason, like it's too heavy and it's not safe. As of now it's safe, but for the further advancements, like right now we are using the pressure vessels or the pressure cylinders like LPG or the gas cylinders, which are made with the steel, which are too heavy. But if we keep the same gas cylinder in the automotive or automobile segment for the hydrogen gas, so it's too heavy, so the range will be decreased. So there are also advancements in the pressure vessels, for example, for the automotive, for the aviation segments also, where it runs from the hydrogen gas storage. Because for the hydrogen gas, like it's which can travel around 350 miles in general, and it has been released by Toyota Motorsport for the hydrogen gas cylinders. And also these hydrogen gas cylinders, like which has to be light and which has to withstand the hydrogen pressure, so it's more safer. So here the industrial springs, medical applications, they're each and every component what you see, even the laptop we would like to have in a lightweight. So here we use a composite plastic and or a carbon fiber placed plastic material. So the fiber reinforced material, which our laptops or anything what we carry will be very lighter and strong enough. So here in the automotive, like here you can see just in the ambassador, like you could see like the stability of this. It's too heavy. And then like in the later stages, this was a car like which is this whole frame, like if you see, it's made with a composite materials by using one of the process called VATM, vacuum assisted resin transfer mounting. So we'll be looking into what's this process and what we can do, what are the advancements in the coming slides. So only to give you a feeling, like I would like to tell you, like these are the applications oriented way. And for all of you like who are looking for the good way to go, exactly you could use this composites field. I would say where you are eligible for almost all the market segments in almost every fields that you would like to go, and also for the satellites which has to be lighter, otherwise like it will be falling on the ground, won't fly enough. So why do we use composite when it comes to the engineering or the engineering perspective? So here the composites are lying. So where the density is around 1.2 mm per cc, it's called gram per cc cube or mg per m cube. So here the boots coming to the metals, like it's around 10, more than 10 here. You could see nowadays, like in the past, like we used to here with the composites where we can reduce half of the weight, almost equal mechanical strength. So coming here, woods and the polymers. So polymers are like with an injection molding with different polymers. We could manufacture the materials, and the elastomers and the foams. Foams are nothing but the thermocol, like if you see, and a honeycomb structure. It's a completely like cotton. Cotton is also one of the foam. So nowadays, like they are using foams to achieve the thickness in the composite materials. That's how we'll be looking into the next slides. So here, like this, we have different fiber orientations. For example, here the lines that you see are the fibers, and in between the white color one is a matrix. So this is a continuous and aligned fibers. If we lie the fibers in a continuous way, then it's a continuous fibers without any breaks or without any cuts. If you just spray the fibers, then it's a discontinuous way, but it's an aligned. So there are three different types over here in the fiber orientations. One is a continuous fibers where there won't be any discontinuity in the fiber stream or fiber path, and the other one is a discontinuous and the aligned one. So the fibers are aligned straight here, but it's discontinuous. There's a matrix in between the fibers in the transfers or in the longitudinal directions. And coming to the last one, like it's just a spray. If we have a, I think we'll see the fiber orientations of fibers. Fibers can be in the form of mats or in the rovings. So we will just spray the fibers and mix the resin and then apply it. So it's a hand and layer process, it's called as. So it's discontinuous and randomly oriented. So here there's three types to be more precise. One is a continuous fiber and the aligned, continuous and aligned fibers, and discontinuous and the aligned fibers in the second column, and the discontinuous and randomly oriented fiber composites. And these fibers are the strength for the composite. These fibers are the reinforcement. These fibers are reason for the strength of the composite materials. So how do we align is of course matters. So what happens with the alignment? If I have a discontinuous fibers, then what happens? If I have a continuous fibers, then what will be the strength? So this fiber alignment or orientation will play a major role for the strength or the stiffness and also the weight of the component, or how much material we use, the composite materials. So here, as I've told you, like fiber, which provides a strength, fatigue resistance, and the Young's modulus, where this is because when we have a good enough strength with the continuous fibers, and then we could use only minimum amount of fibers and the resin, so that it has a good enough strength to weight ratio, which is called stiffness over the other materials of the, for example, when you see with the steel or aluminium. So it can be achieved by incorporating strong stiff yet brittle. So even the fiber materials, so the fiber materials depending on the application, like the fiber material can be ductile, can be brittle, can be, it depends on which fibers we select. So here there are different types of fiber materials that we'll be seeing. And the fiber supplies, as I've told you, like the fiber supplies the strength and stiffness. And the main purpose of the matrix is to bind the fibers and gives the dimensional stability, and it's mainly used to transfer the loads between the fibers. So these are the reason for the fiber materials. So here, so to summarize the things, the fibers give the strength, the resin or the matrix gives the transfers the loads into the fibers, and it gives the dimensional stability and protects the fiber from the environmental impacts. So it protects the fibers without further damage or further breaks. So this matrix material protects protects the fibers. The fibers gives the strength and stiffness, and the matrix gives the stability or the dimension. So if you want to look a component in the form of some T shape, for example. So this T shape, the fibers are aligned in this direction, in the horizontal and in the vertical directions. So because the fiber is like a raw material, it's like not a soft material. So these fibers, it spreads. To make it into one place, we add the matrix material, which gives the dimensional stability, and it transfers loads from loads to the fibers whenever it is necessary. So these are the for fiber composite materials. And what are the characteristics? Let me show you the fibers, so then it will be easy for you to. Yeah, these are the fibers. For example, these are the rovings. These are the fiber materials, which are one type, like the rovings. And the fibers can be in a form of matrix and in a form of these sheets in a woven, like what we see in the saris and this all. So they use the fiber materials, they'll be stitching it. So this is in the form of mat. So this is one type of fiber. And this is a carbon woven fabric. So these are some of the, I think now you could see. So here, what are the factors that we have to consider during the making a product? So here the length, the diameter, the orientation. That's what I have told you. Like it's randomly oriented, or it's continuously aligned, or it's woven or not non-woven. So how the fibers are aligned, which plays a crucial role. So the orientation, I have told you the importance of the orientation, and the amount and properties. So here we could use 60% fiber and 40% resin. So 60% more strength and 40% resin, and the bonding between them. So which resin or which material, as I've told you in the initial stage, like when we make a roti, like we have some of the powder, which is a fiber, a short fibers, let us consider, and the water, which is a resin. So here the floor and the water is a good compatibility. So in place of water, if you mix some Dettol or some different water, then it won't mix properly. So the compatibility between the fiber and the resin should be tested, should be identified. So these are the factors that we have to consider. One is the length. So depending on the length, the orientation will be there. If it's a short fiber or the long fiber, it's the length. And the diameter. There, the diameter, to give you an example of the diameter, um, here you could see like 1 filigram. It has from 10 micrometers to 500 mm. So it depends what we have to consider in terms of diameter. So if it's more, then we need less material. And then, yeah, it depends. The strength always depends on the size of the filaments over here, or the size of the matrix over here. So always the diameter of each and every roving or the fiber, which plays a crucial role that we have to consider when we are making a design or when we are making a product out of it. So based on all these characteristics, the final product output or the final product properties will be determined based on considering the length, the diameter, the orientation, amount of fiber, like what's the ratio between the fiber and matrix, or for example, in general terms, what the ratio between the flow and then the water. So if we add 50 grams of water and then 50 of water, 50 grams, then it might be loose. So we have to make it in a form that it has thick enough. So that's the reason why like the amount and properties of the constituents are very important over here. The final product, as I told you, like it's all mainly depends properties what we need. So then the above characteristics or the above factors which will be adding into it, which will be considering, and then we'll be making our final product properties into our grip or into our control. Yeah, mainly the fiber dimensions, they are mainly characterized by the aspect ratio. This aspect ratio is nothing but length by diameter. So what's the length? As you have seen here, like this is a length and the diameter is how much thick that it's there. So based on the L by D aspect ratio, the fiber dimensions will be characterized. The strength if the aspect ratio is large. So what does it mean? The aspect ratio is large. So the length, so if the aspect ratio is large or infinity for the continuous fiber, so the strength will be more higher to the continuous fibers than the normal short fibers. So it's directly proportional. The aspect ratio is directly proportional to the strength. So if we need more strength, we have to use the long fibers or the more L by D fibers, so that we have to cut. We have to use better, meaning like we have to cut long fibers. Suppose if we are now getting into this strength, so we have to increase the size L by D so that we'll be having a good strength, good aspect ratio. The strength always depends on the L by D and the other factors also, but the most of the strength depends on the aspect ratio. So here in general the diameters will be 10 mm. So you could see like 10 mm, and in terms of rovings it's 10 micrometers. So like there's some of the products like 24K, 48K. So this 24K meaning like there are around 24,000 small fibers, strings, each and every string. So to 48K, 48,000 in this 10 you could imagine how small there will be there. They are always, there will be also some of the backlogs or some things, for example, due to the surface imperfections, when we are not aligning the fibers in the right direction, the right way, due to the surface imperfection, there will be a fracture which occurs, and this fracture causes a failure. So making the small fibers or the small fiber diameters will reduce the surface area, and which has a few of flaws, because the surface will be very good when you use a smaller, or when we use the diameter over here a smaller, and L by D ratio is bigger. So long fibers are preferred because like they can easily carry the loads from one point to the other point without any disturbances or without any breakages, I would say. So here the long fibers gives more strength than the short fibers. So to conclude here, the long fibers carry more load carrying capacity than the short fibers or the randomly oriented fibers. So here you could see the strength of these are some of the tests. Yeah, so here there are different types of fibers that we use. For example, the glass fibers, which is made, where the glass fibers, as you all are familiar, they take from the rock, and they add some of the silica material and different proportions. They make a glass fiber and the carbon fiber also, and there is also some of the natural based, like the basalt fibers and the flax or the hemp. Yeah, there's rayon. So there are lots of natural based fibers, where we can take it from the nature, from the environment, or from the plants or trees, so that the product what we produce will be recycled easily. So here so coming back to the point, so the strength of the composite increases with the fiber length increases. So here you could see, fiber length in inches. Like if we use 0.25 inch, then this is the strength. So if we have 1.5 inch, then this is the strength. So it's a continuous process. So it's a linear graph that we could see. When the fiber length increases, the strength increases. These are some of the tests that we have done. So these are the results, the test. And the orientation, as we have seen, when the fibers are oriented, for example, this is one of the orientation. When the fibers are aligned in this orientation, if you see my camera, when the fibers are aligned in this orientation, then if you pull, then there is a loss of strength that these fibers can withstand. So when we use in a horizontal way, and then when we pull them, these two are fibers which are joining each other. If you pull in this direction, then it's too easily comes out. It has less strength. But when we keep this, and then if you pull in this direction, so it can carry more loads. That's what here we can see. Here the long fibers are oriented parallel to the applied load. So we have to use the fibers more intelligently, so that fibers are placed always in the parallel to the loads. So here this is an orientation. So if we make a 45 degrees plate, all the fibers which are in a 45 degrees, 60 degrees. So this is an orientation. So when we are making a mechanical test, when we orient the fibers in the parallel to the loads, then it has more strength when we compare to the horizontal loads. So here this graph, here this views a slope that you could see, like it can withstand only 50 megapascals, but the same materials, if you place it in the parallel direction, it could withstand more than 400 megapascals. So it's 3 times or 8 times more. So it's all how we use the fibers, it's always matters. So here, to achieve the thickness, when we use a composite sheets, fiber sheets, which can be called as pre-pegs, for example. These pre-pegs, when we use them, it depends. We can tailor the composite materials, one in this direction and the other one in this direction, so it can withstand in all together all the strengths which are, all the loads which are acting. So we could withstand all the material properties by the orientation of the fiber materials. Yeah, that's what it said. So you could see like there are different orientations over here. This is a cross-plied quasi-isotropic. This is a unidirectional composite materials. And we can also make a 3D structure. So these are all the filaments over here. So we can place the fibers in all the different directions, what we need and what a 3D structure can be formed with the composite materials, with the knitted or with the waved, by using a waving technology or knitting technology, or by using mats which are already prepegs which are made. So so the fiber properties, basically they are the specific strength. Specific strength is nothing but the tensile strength by the density of the materials. So here the fibers are stiff, strong, and lightweight. Basically, we could reduce more than 80% weight reduction compared to the steel or aluminum, more than 8 times or 9 times. So when you have a 10 kilos, it can come to 800, 700 grams by using an intelligent composite materials processes. There are different composite manufacturing processes that we'll be seeing in the later stage, how the composites materials are manufactured. So this is only the theory or the basic understanding of how the fiber orientation or the fiber materials that will be, what are the properties that change, how can we align the properties. These are only the basic understanding, and in the later stage of this webinar we can go with the composite manufacturing process, where we'll be seeing the real manufacturing process of composites. So yeah, these are the specific strength that we always look into the thing by always testing in the tensile test, or the bending test, or with the Charpy test, various tests. We'll be always looking into the specific strength and specific modulus. So as I've told you, like there are different processes like glass fibers, with carbon fibers, with an aramid, with a basalt, with flax, with a hemp, with a various other fibers that we could use. So these are the commonly used, and matrix of polyester, for example, a thermoset polyester, unsaturated polyester. So there are different matrix thermosets and thermoplastics depending on the process we'll be using. For example, only to give you a short information regarding the manufacturing process, like the thermoset manufacturing process and the thermoplastic manufacturing process. So this thermoset manufacturing process, basically it's like thermoset is like an omelette, like if there are some, it's like an what we cook in a regular life. You could imagine like it's an omelette, like when we pour a liquid, or when we pour the shell or the inside core, and when we heat it, then it becomes strong, it becomes hard. This is thermoset. And the thermoplastic is like a cheese. When you keep on the stove, then it melts. So here, with increase in temperature, the thermosets will be getting stronger and hard. When it compares to the thermoplastic, when we increase the temperature, it becomes soft and it becomes in a liquid form. And in a controversy, and in the other side, vice versa, when we decrease the temperature, the thermosets will be not in a hard form, and thermoplastics can become hard. So from these, in general, the thermoplastics are easy to be recycled. So most of the industries will be using thermoplastics and then thermoset composites. But the thermosets, it has its own advantage. It is more stronger and structurally more dimensionally stabilized with the thermosets. So there are the pros and cons in thermosets and thermoplastics. The usage or the decision making has its own pros and cons. As I told you, like these are the forms of the reinforcement. These are one type of fibers, and these are the mats. So where what you have seen here, they are aligned in a form of mat, the weaving, like when we see like a cloth manufacturer, like in our home, in our villages, we'll be seeing the cloth manufacture, which is weaved. So in the same way, the glass or the carbon or the X fiber that they'll be taking and then we'll be weaving. So these fibers applications we'll be seeing in the next slides. So this is a carbon fiber woven fabric. So, and coming over here, like a hand layer process or the spray layer process. So this is one of the real-time application that it's there from 1900s, 1800s. People are using this application. So here, what they do is they'll be taking this mat or the woven fabric, and then they'll be placing on a sheet or on the, for example, on a mold, and then they'll be applying the resin. Resin is like a water, so they'll be applying the resin, and then they'll be keeping the other mat, and then they'll be applying the resin, they'll be keeping the other mat, they'll be applying resin. But as we have seen, these orientations determines the property, because one can be oriented in this direction with the fibers and the other can be in this direction. So it depends on the thickness, what we need. The fibers are just piled up by keeping the resin in between, which acts as a binder. So this is a hand layer process here, you could see. And coming to the spray, it comes in the reverse direction. They'll be keeping all the resin, and with the jet here, what you see, they'll be just spraying the whole fiber, or they'll be just spraying the whole fiber materials, a short fiber ones, which comes with a greater velocity. They'll be spraying it so it sticks to the mold. So it's similar to the glue. When we have a glue on the ground, if we keep the hand, then it sticks. So in the same way, the resin that they'll be applying to the mold, and then they'll be using a spray gun. They'll be spraying each and every place. So this fiber will be settling over there. Then the final will be like it's complete, and then they'll be removing it from the mold, and they'll be using it in the real circumstances. So the pros of this, like if one of you would like to, but it's a very old process technology, so it's like it requires low initial startup cost, easy to change the mold because of the wax or because of the release agent that we keep. The mold is easily, the material or the composites, it can be coming easily out of the mold. And the cons are basically it requires more human effort. It's not an industry 4.0. So it requires a human effort and human preciseness. It's always each and every part differs individually. It depends, like if I make a part, then I'll be spraying more at one section, and then you'll be spraying at different sections. So it's all different properties that we achieve with the hand laminate. These can be used only for the prototypes or for the testing, for the initial ideas, how the material properties looks like. So it's a hand layer process. So based, like if we need only specialized, if we need only customized product, then they'll be going with the hand layer process, so that they'll be having only one or two. They doesn't require much investment, a big machinery to make this. And this is a pultrusion process. In the pultrusion process, as you can see here, these fiber rovings. So these fiber rovings are these. So each and every fiber rovings will be coming, and then they'll be impregnating into the resin bath. So, threads, we term it as threads. All these threads will be coming individually, and then they'll be going into the hole where all these 10 different threads, which will be with in a tensional form, going into the guide curve, and this guide curve they'll be impregnating into the resin bath, and then there will be an external mold, so where the pipes or where the final composite structure which can be formed. So these pultrusion basically they'll be using for the profiles, the window profiles, like you could say. They are made with the pultrusion, and there's cylinders or the carbon rods or the glass fiber rods. All these are used with the pultrusion processes. So yeah, when we come to the text, it's similar to the extrusion of the metal parts, but here we use a fiber materials in respect to what fibers. So here they use a fiber materials and the resin impregnation, uh, an extrusion of the metal parts. There's a die. The melting steel will be going into the die and then it comes out. So here in the similar way, the resin mixed, enriched, the fiber material will be placing into the resin bath and then it will be coming from the mold, such as pipes, eye-shaped beams, and all these can be manufactured. So here we can, all these fibers are in a continuous oriented. So these are very strong and stiff and very ultra light. Completely, you can hold a big pipe within a single hand. So it's completely ultra light pipes, which can be produced with the pultrusion process. So this is a filament winding, as I've told you a lot regarding the hydrogen tanks. So these hydrogen tanks, in general, the LPGs, what we have at home, these are the LPG cylinder internal core, and then there'll be winding. So here to give you the process, these fiber spools, what we have seen in the earlier, similar to the pultrusion, like these fibers spools, like which will be mixing into the resin, and then they'll be coming. So this mandrel which goes in the transverse direction and also in the rotational direction. So here, with the help of the tension, it can be spreading in all the directions. So for example, to give you an understanding, we have different types of stresses over here, the hoop stress and then hoop stress or the circumferential stress or the axial stress in this direction. So that's the reason why like people will be binding in these directions, and then there'll be also to stand axial loads, they'll be binding in this direction also, the transverse direction, and then they'll be winding here. So we can customize the whole thickness by using a simple max, and there are lots of equations by using to we can determine the trajectory of the materials, and then we can push in different directions. So all the fibers can be sprayed in different angles, different orientations, different. So we have to set all the parameters by mechanically, but the reinforcement over here is a fiber and a matrix. And so here to give you more, and then in the last step, like here, they'll be taken into the curing oven and then it heats. So we are using a curing oven in the last, and it means the thermosets. So here, all these manufacturing processes are related to the thermosets. And coming to the thermoplastics, we use injection molding, different. There are lots of automatic taping. So there are lots of different things that we use for the curing and to make the component hard enough. So this is a Vatam process, vacuum assistance. So here, if you see, this is a mold or this is a shape, for example. So the fibers are placed, these mats are placed, and on top of the mats, we use a breather, which spreads the matrix, and then it's closed completely by the vacuum bag. And then there is a vacuum which is generated by using a compression cylinder. Then the vacuum is generated. We just need to keep there's an inlet for the resin to enter inside, and there is a vacuum bag on top of it, and then there is a compression cylinder. So as there is a compression cylinder, it means it sucks all the resin material. So then the resin spreads the whole fiber or the mat. So then it gets cured for around 12 hours or 8 hours, depending on the resin. And then the component is ready. So this is one of the polymer matrix, one of the thermoset manufacturing process. So it's mainly driven with the vacuum. The resin is spread all together with the vacuum. So it's a vacuum oriented resin transfer molding. And Yeah, you could see like this is an inlet of the fiber, this is an inlet, and then this is a vacuum. So because of the vacuum, the whole section is vacuumed, and then it sucks all the material. So here the resin is transferred in completely over the mat over here, and then it becomes a stronger material, a binder which is added. That's the matrix. So coming to the conclusion, like when we need to have a high specific strength is nothing but strength by weight ratio. So here we can have a high tensile strength, bending strength, shear strength, with around 8 times less the weight than the carbon, than the steel, and 4 times, 5 times less than the aluminium. So here we can have the lightweight materials also. Lightweight, which reduces. So I'll just tell you an importance of the lightweight. So here if our car is lighter, then we can travel more range in automotive. So if the aeroplane is lighter, then it can travel, it consumes less fuel and it emits less emissions, and then it can increase the range. So in each and everything, the lightweight is, which is very plays a crucial role. Lightweight and also the safe. The safe is nothing but the strength. So we need to have the lightweight and the strength. Then we need to use a composite materials. Unlike the aluminium, like if you see the aluminium, it's corrosion. So because of the corrosion, the material properties always decreases when there is a corrosion from the environment that acts. So these composite materials are the corrosion resistant. We can add a coating on it, so which is a corrosion. With or without a coating, it's a corrosion resistant materials, and there are different and various composite manufacturing processes. So it's completely flexible manufacturing processes which are not so difficult, or which we do not require a high end mixing or different proportions. So and the degree of freedom is also completely high enough, so there are different manufacturing processes. So depending on our product complexity, we could choose the process technology which drives the degree of freedom. And there, as we have discussed, as I've told you in the last 40 minutes, it has a wide range of industrial applications. So it's completely unlimited to the different in each and every industrial segment. These materials are being used and will be converted in the future. Right now, whoever are not using it. So yeah, and this is, so if you have any questions, please free feel to answer.
Yeah, anyone, any questions? Thank you, Bhargav. Just I would like to summarize what Bhargav said. So he has given a good glance in the given time, like very limited time we have. He has blended us to go through different things, like starting from what is composite to the manufacturing product, that is output of the product, in a very good, efficient way. So he suggested like different composite materials have different patterns, and according to the use and applications of it, everywhere we'll be used. Any product we'll be using only for two purposes: efficiency, that means strength or efficiency, it will both same. Another one is manufacturing cost based on the materials. So composites can be of various materials starting from metal, bio and glass, polymers and so many other things. And also he discussed about the orientation of the polymers in different directions, and mentioned that based on the orientation, how the product is effective and efficient with high strength. So based on the application of the product, we have to go for orientation, because it depends on, if you are using in something like aero industry, you have to have very lighter material with more efficiency, whereas in household things can be of through spray method or some hand method, that would go good enough in terms of cost efficiency and also in terms of strength wise. So also he explained one of the products, like the process, like Pultrusion process. There were so many processes are there. He explained about it, how based on the long fibers, how it is getting converted. If you observe in day-to-day life, we are playing with lots of composites, starting from the wire and everything. So even the electric wire where we are fixing, in which the small fibers are there, which will roll as a strand. The same is here the filament. So then it is combined with plastic to form a complete wire. So this combinations of each and everything, if we observe whatever we are doing on daily basis, everything is a part of composite. Okay, please make use of it. And if you have any questions, uh, Bhargav expert is here. You can ask him.
Any questions?
Yes, hope you got that content. I think that's why there were no questions. We are happy for that. Then we also mentioned about the participation certificate. Whoever has participated, please, Bhargav, can you go to next slide?
Yes.
Thank you, Bhargav. Please reach out to this contact number. Just message us to WhatsApp so that our executive team will help you to provide the certificate. Thanks a lot, guys, for attending. So everybody's time is precious, and we are giving to share the knowledge here, that too with free of costs from various industry experts. Make use of it. Thank you a lot. Thank you very much, Bhargav, for accepting our invitation in
Thank you.
very short time. And it was a great and excellent presentation the way you have made. We are very
Thank you.
glad to that you have accepted our invitation and made it in a good way. Thank you. Thanks a lot, Bhargav.
Thank you.
Yeah. Thank you, everyone. Bye, guys. Have a happy weekend. Meet you in next webinar.